Hey everyone, in the previous video we downloaded Anaconda and added it to our path variables so we could run it from command line. In this video we'll be going over these two important topics. First one is how do we create and manage virtual environments using Conda, and we'll also be delving into .conda rc file, which is Conda's optional runtime configuration file. It's optional as in it is not created when we download Anaconda, but it will be created under our user directory the moment we use conda config command. And we'll see how that happens and why that is useful. Let us start our PowerShell and run some sanitation commands to check our Conda and Python versions. So if we check our Conda version, it should give us the version which we downloaded, and if we input Python version, it will give us 3.11. So both of these obviously came with the default Anaconda distribution. If we want to list all the virtual environments which we have in our local machine, we can use conda env list. Obviously in this case it would only give us the base or default environment, right? That is the default Anaconda distribution which we just downloaded. So let us create our first virtual environment, and the command for that is very simple. It is conda create. You can either use -- name, or you can simply use one hyphen with n flag. Either of that will work, and you can give any name for your environment. I'll give .myenv, and that's it. So it has started creating the environment. I want to proceed, so I'll just write yes. So our environment is created, and now if I list all the virtual environments I have in my machine, it will give me two of them. One would be the base environment, and second would be the one which I just created. And another thing to note is that if we use the command that we did, conda create -n or -- name, by default it will create the virtual environment directly under your Anaconda directory, env's folder, and you can check in your distribution, right? So you can go to Anaconda env's, and this is where the environment will be created. Obviously right now it doesn't have much because we have not installed any new packages with it. Okay, so now that we have created a new virtual environment, let us try activating it. So anytime we switch from one virtual environment to another, in Conda it's called activating an environment. So let us type conda activate, and first we want to activate base, so let's try that. Okay, so sometimes what happens is if you are working with conda activate command for the first time from PowerShell, it can give you this error. It's not an error, it's just telling you that initialize your PowerShell to work with conda activate command. In that case we can use conda init PowerShell. Right, so it has modified. See, one of the things it modified was activate.bat file under our scripts. So if you go to Anaconda scripts, it would have this Windows batch file, right? And that is what it has activated. So next time when we use activate command, it will work. But as it says, for this to take effect, we'll have to close and reopen our shell. So let us do that. Right, so you can see this time, because our PowerShell has been initialized to work with conda environments, the moment we opened it, the base environment was automatically activated, and it prefixed our prompt. So this is how we know which environment we are currently operating on. If we want to activate our newly created environment, we can simply use this command, right? So conda activate.myenv activated our .myenv environment. We can also mention specific versions of package or specific version of Python while creating virtual environment. So for example, let us deactivate this environment, right? So the moment you do conda deactivate, it will switch out of this .myenv and jump to our reference or base environment. Okay, so let us create new virtual environment from here, and we'll name it .myenv2, and this time we want to also download a specific version of pandas, an older version. So currently pandas version would be 2.0 something, but we would be we'll be creating this virtual environment with pandas 1.5. I want to proceed, yes. Right, so it has already mentioned some of the packages which it would be downloading by default, and you can see pandas is 1.5. Had we not mentioned it, it would have downloaded pandas 2.0 by default. Right, so let us clear this and let us activate. We can also like do a status check how many environments we have, and it should be 3, and it should also be 3 environments under our Anaconda envs folder. Right, sorry, there'll be 2 environments because one is the default Anaconda distribution. Okay, so now let us activate. Right, let us first activate .myenv, right, and let us start our Python interactive shell and check out what version of pandas we have here. It's a huge module, right, huge package, so it will take a while to import. Let us check out the version. Right, so you can see it's 2.1.1. Let us exit, and now let us activate .myenv2 and right, it is 1.5.3 because we explicitly mentioned this version when we were creating virtual environment. So now let us exit out of this. So that's one way of creating virtual environment. There is also another way of creating environment, and that will be by using, instead of name flag, we'll be using prefix flag. And what this does is, when we use name flag, by default it creates the new virtual environment directly under the Anaconda distribution like we discussed here. But a much better practice is to create our virtual environment directly under the root of our project. So let us just create a sample directory here under this folder. So we can create a new directory, our first project, and then we can cd into that directory. Right, so this is our project. So now that we are in our root project folder, let us create the virtual environment directly under this directory. And in order to do that, the command would be conda create, and instead of name we'll be using prefix flag, or you can also use, so you can either use hyphen prefix or you can use -p. Both of them will work. And let us name our virtual environment. So I always like to have dot before all my environment names, but it depends on what convention you like, or what convention the project you're assigned to has. So we'll just have this as the environment name, and we'll also explicitly define what pandas version we want. I also have to mention that it's relative to where I am, right? So I have to have dot /. Right, so it is downloading pandas version 1.5, and I want to proceed, yes. So as we can see, it has finished creating the environment, and let us check it out. Right, so we can see that it has been created directly under this first project folder. So let us activate that. All right, so one of the things to remember about when we create virtual environments using prefix flag, it becomes important to mention their relative or absolute path whenever we want to activate this, right? So because we are activating dot first project env, which is directly under this project where I'm currently at, we have to indicate that explicitly, otherwise it will give us an error, right? So this is this will work. Another way is if we just mention the full path after activate, that also will work, but you have to indicate where it is in terms of its location. Whereas in case of .myenv and base, we could simply write conda activate .myenv and it will end up getting activated, right? Because it is directly under the Anaconda envs folder. Okay, so let us activate our new environment using full path this time. So we'll just copy this. Oh, yeah, right. We have to bound that in double or single quotes, otherwise it would not work. So another difference when it comes to creating environments using prefix flag is, just as we had to be cognizant of absolute or relative path while activating it, that path also shows up in our prompt, right? Whereas in previous cases it was just base or .myenv instead of like full location of where the environment is. Okay, so if we want to change this and only have the name displayed on our prompt, then we can do that by using this command, conda config set env prompt, and then in single inverted commas as well as in parenthesis name. Okay, now before pressing enter, just note that we are using conda config for the first time, right? So if this is the first time you are using this command, it will end up creating .conda.rc file directly under your user directory, right? We can confirm that we don't have any such file by going to the users directory, math and machines, and let me make sure that I'm turning my hidden items on, right? So we don't have .conda.rc file yet, and the moment we run our first conda config command, it will generate it and it will add this configuration to that file, right? So now I can go there and see it created conda.rc file, right? You can open it with Notepad. It's a very simple file, so you can see that it has added this command. You can also manually create this file directly under your users directory and add this command. It will also work that way. And what .conda.rc file does, as the name suggests, right, it is a runtime configuration file. So whenever you run Python commands, it will check if there is any conda.rc file, and whatever configurations are set there, it will make sure that those configurations are followed. Okay, so now we'll have to restart our shell for that to take effect. Okay, so it has already activated base by default. We will do some sanity check, list down our virtual environments, right? And it's interesting, right? So it doesn't have a shorthand name for this environment, which we created using -- prefix flag. So let us, right, we created our first project here, so we'll just cd into that. And we'll create, we'll activate our environment from here. Okay, and so now that configuration has taken effect and we can only see the name in the prompt instead of the entire absolute path. Let us create a very simple Python script just to drive home the point as to why you need virtual environments when you're developing data science projects on your local machine, right? So let us create new item. It would just be our first script .py, and then we can, for now we obviously haven't yet downloaded VS Code, right? So we won't be using that. We'll just be using a simple notepad to write our script. Let us open it in the notepad. And it's going to be a very simple script. We'll just import pandas as PD, and say you have a list of date objects, right? And in fact, they are not date objects, they will be strings, but we will have date values in them. Okay, so let us create a series out of our list of date strings. If you don't know pandas yet, it's okay. We'll dive deep into it in some of our later videos. For now, just remember that a pandas series would be equivalent to an Excel column or an Excel row, whereas the entire Excel spreadsheet with columns and rows both would be what we'll call data frame, right? So that will be the two-dimensional Excel spreadsheet, right, with multiple rows, multiple columns. And our series will be a one-dimensional Excel column, or it can also be a row, right? Basically anything that you can imagine as a list of items can be converted into a series using this pd.series function. And we can also define, by default these are all in fact, let us print our series, right? So we already have that script and we can run our script. Right now, what you need to remember here is that even though we have our default Anaconda and Python that came with it added to our path variable, because we are in an activated environment, the Python that will be used for interpreting our script would be the one that is there in this environment and not the one which we downloaded with Anaconda, right? So we will use Python for script, right? So it took that the list of date strings and printed them out in a column, right? So this is a series in pandas, and you can see the data type for each of those values is an object, because in our list we had them as strings, right? And we did not change it to date objects. Another thing we also might want to check is our version of pandas, right? So because we had explicitly mentioned our version for pandas to be 1.5 when we created this environment, right? So we expect it to be that. Okay, so let us again run that. Right, so our version is 1.5.3 and this is a series object. Now within pandas, as well as NumPy, which is another important package on which pandas is based, we can also define a D type or data type for date objects, right? And there is a default data type called datetime 64-bit with nanosecond resolution. We can also have other resolutions along with this, but we'll get into it later, right? So if we run this, it will give us, oh right, because I used it as if it's a variable, I needed to use it as a string because it's an argument to D type parameter, right? So if we run this, and you can see right now D type instead of object, it is, right? So it was object here and now it is datetime 64-bit with nanosecond resolution. In pandas 1.5, the only resolution available was nanosecond, right? So even if you use some other resolution, for example, if you use second or if you use day, right, all of this will give you nanosecond as an output in terms of its data type. So let us run this, right? So even though we had day as our resolution, it's still giving us nanosecond here. Let us keep day as a resolution and let us try to switch environment. So we had .myenv environment, right? Because that was the environment where we did not specify what version of pandas we want to use. So we'll just activate that. And in this case, now we don't need to give absolute or relative path. We can just activate it directly. Now let us run Python command here along with our script. And again, the Python that will be used now will be the one which came with .myenv environment. And more importantly, the pandas version that will be used here would be 2.0 or 2.1 rather, because that we did not specify 1.5 when creating this environment. So let us run this and see. It broke your code, right? So the version of pandas is 2.1.1, and it is telling you that the resolution day, right? So if you look at the error stack, the summary of the error would be that d-type date times 64-bit with day as resolution is not supported, and only resolutions that are supported are millisecond, microsecond, and nanoseconds, right? So this is a very simple use case as to why virtual environments are important to containerize your code, because we wrote our code in an environment where the pandas version was 1.5, which is why we got away with this. But if we update our package version and if we update the pandas version, then this code breaks and it's no longer working. And obviously in this case it's just one line, so we can go ahead and change it and it will be fine. But usually when you develop something for months, it will be a huge code base, right? And you want to be careful that whatever package versions or Python versions you worked with while developing your code, you fix those versions for that code base in an environment, right? You containerize or isolate it. And when you move to your new project is when you actually update your packages and Pythons to whatever new updates are available then. Now, before I end this video, one last thing that I like to discuss is whenever you want to install something in your environment, right? Say for example, so let us activate our first project env. Okay, so now let us start a Python interactive session and let us try to import matplotlib, which is another important package like pandas and numpy, right? So we don't have any module because it did not get installed. It did not come pre-installed with Anaconda. So it means we'll have to install this package, and this is where we use command conda install, whatever the name of that package is. Okay, now before I press enter, another thing to remember is whenever we run this command, our conda would be looking at channels or repositories where from it can download these packages. Now usually by default it will look at Anaconda's repository, but there is another famous channel which is also very useful for downloading a lot of data science related packages, and that is called Conda Forge. So if you so you can check that out for yourself, and it's a community driven collection of recipes or packages, but by default your system would not be configured to look in Conda Forge to download packages. It will only look at Anaconda's default repository. This is where we add another configuration to our system, or rather our conda rc file, which would be conda config add channels conda forge, right? So what this will do is it will add conda forge to the list of default channels where our installation command will look at whenever it comes to downloading packages. So we can confirm that that configuration has been added by referring to our .conda rc file, right? So you can see that conda forge is now, along with defaults, our list of channels where whenever we run installation command, conda will be looking at in order to download packages. So now that we have that set up, we can just restart our shell for that to take effect. And always remember to check which environment is activated. So we'll have to right? We don't even need to cd into our project. We can simply activate it from here. We just have to remember the path for that environment, right? So it will be first project, and underneath that there will be dot first project env, right? And we can run our conda installation command to install matplotlib in our dot first project env environment. Yes, I want to proceed. And you can see this line here, right? So Conda Forge is our higher priority channel. So it will look at Conda Forge before it looks at Anaconda's default repository in order to download this. And it will only go to Anaconda if it can't find it in Conda Forge. And the reason is that if you look at our Conda arc file, in the list of channels, Conda Forge is listed first. So by default, it will look there before it looks in defaults. Okay, so now that it is downloaded, we can start our interactive session and check if it's imported. And it is, right? It did not give us any error. So that is it on how to create virtual environments using Conda and how to track your configurations in Conda RC file or by using Conda config command. Thanks for watching this, and in the next video we'll be setting up VS Code for data science.